Good morning, good afternoon, good evening, wherever you are, whenever you are, whatever you are. Welcome to this week's podcast. This week we're taking a deep dive into something that I've been fascinated about for about 20 years now, but has only recently been published in a proper scientific journal. We are talking about the Silurian Hypothesis. As far as we know, Earth is the only planet which life has existed on and continues to exist. And it is also the only planet known to have given rise to at least one industrial civilization, namely ours. A civilization of this kind made up of beings capable of using external energy sources such as fossil fuels or solar energy on a global scale has existed on our planet for no more than 3 centuries. Its origins date back to the Industrial Revolution, which has provided the means to transform local economies into highly integrated systems capable of ensuring mass production of an ever-growing number of goods and the ability to alter the environment globally. As members of the only known industrial civilization, we face alone, at least for now, 2 vast immensities: space and time. As far as space is concerned, we know with reasonable certainty that at least from here to Pluto, there is no other industrial civilization and not even any apparent sign of life outside of the Earth. This conclusion is supported by the large amount of data collected by many probes that we have sent far across the solar system. If other civilizations existed beyond Pluto, we can only imagine it, but our ignorance in this regard is total. Of course, we know that there are many planets that orbit other stars other than the Sun. In just over 2 decades, thousands of them have been discovered thanks to the Kepler Space Telescope and other sophisticated instruments. From the ratio between the number of extrasolar planets discovered so far and the total number of stars observed, we can infer that there are probably 10 billion habitable planets at least in the Milky Way. Too many to even count them. But there is a big issue with them. Those planets are all out of our reach by a hell of a way. Even with technological means available today, we can at best discover some element in the atmospheric composition of an extrasolar planet not too far from Earth. Next generation telescopes such as the JWST and the ELT will even detect the presence of any atmospheric biomarkers such as methane and oxygen. But seeing the signs of industrial civilization on other planets distant by tens, thousands, or even hundreds of thousands of light years from us is for now something belonging to the realm of science fiction. The only chance to breach this abysmal wall of ignorance would be to pick up an intelligence signal of some kind, which SETI project has been trying to do for decades, but unfortunately without any success so far. The big takeaway from all this is exploring the space abysses in search of another industrial civilization is therefore a massively arduous undertaking. But it is equally challenging to carry out the same search through the time abyss, even without moving from the Earth. We know that from fossil records that complex life forms evolved on our planet over 500 million years ago. We also know that evolution does not proceed linearly, but follows a rough path that passes through life explosions and mass extinctions. We also know many technical solutions to explore and manipulate the environment, such as eyes and wings, have been invented several times over millions of years by entirely different species in response to similar evolutionary pressures. There is then a question to ask, seemingly bizarre but quite reasonable. Is it possible that some other intelligent species existed on Earth in the distant past and created an industrial civilization somewhat analogous to ours? And another question immediately rises from this. If another industrialized civilization ever existed, what geological traces do we have to look for to prove its existence? Because don't forget, modern humans have only been around for about 200,000 years, but life has existed on this planet for 3.5 billion years. That leaves 3,495,888,000 pre-human years unaccounted for. More than enough time for the rise and fall of not one but several pre-human industrial civilizations. Same screen, different show, same field, different team, an entirely other race with other technology, vehicles, folklores, and fears beneath our familiar sky. There's been no evidence of such bygone civilizations, built objects, and industry lasting longer than a few 100,000 years. After a few million, with plate tectonics at work, what is on the surface, including the Earth itself, will be at the bottom of the sea, or at the top of a mountain. The oldest place on Earth is a stretch of the desert in Israel, which is just over 1 million years old, which is nothing on the geological clock. And the result of this is quite possibly one of my favourite and I think least explored theories in history. And it's not a conventional conspiracy theory, as that usually involves some sort of nefarious elite keeping the whole thing secret. In this case, the secret, which belongs to the Earth itself, has been kept from all of humanity, which believes it has done the only real thinking and the only real building on this planet, as it once believed the Earth was the center of the universe. In 2018, Gavin Schmidt, a climate modeler at NASA's Goddard Institute, and Adam Frank, an astrophysicist at the University of Rochester, came out with the Silurian Hypothesis. Schmidt had been studying distant planets for hints of climate change using hyperthermals, a sort of quick temperature rise that might indicate the movement of civilized industry. It would suggest the presence of a species advanced enough to turn on the lights. Such a jump, perhaps resulting from the release of carbon, might be the only evidence that any race, including our own, would leave behind. Not the pyramids, not skyscrapers, not styrofoam, not Shakespeare. In the end, it will only be known by the change in rock that marked the start of our current geological era. It was logical for Schmidt and Frank to turn their attention from the upper to the under, from the cosmos to our very own Earth. Why look for alien life there when we might find it here, removed not by miles but by years? There was indeed a mysterious jump in surface heat 55 million years ago. Global temperatures rose from 9 to 14 degrees Fahrenheit. Called the Paleocene-Ecene thermal maximum, it left the same sort of geological evidence that will be left by our own current carbon binge. There may have been other jumps, but we wouldn't know about it, as the geological record only goes back so far. We live in a compactor where all things get crushed, recycled, and returned as new after all. A meteor could have caused the thermal maximum, or it could have been the eruption of a monster volcano, the sort that presently smolders beneath the Atlantic. Or it could have been caused by the awakening of an ancient civilization which rose like we rose and fell as we inevitably will. That could be the fate of all advanced species, a rise and fall that flows as naturally as the changing of the seasons. Such a universe is ironic, continually creating characters whose technology brings on the very end they're trying to avoid. It was logical for Schmidt and Frank to turn their attention from the upper to the under, from the cosmos to our very own Earth. Why look for alien life there when we might find it here, removed not by miles but by years? There was indeed a mysterious jump in surface heat 55 million years ago. Global temperatures rose from 9 to 14 degrees Fahrenheit. Called the Paleocene-Ecene thermal maximum, it left the same sort of geological evidence that will be left by our own current carbon binge. There may have been other jumps, but we wouldn't know about it, as the geological record only goes back so far. We live in a compactor where all things get crushed, recycled, and returned as new after all. A meteor could have caused the thermal maximum, or it could have been the eruption of a monster volcano, the sort that presently smolders beneath the Atlantic. Or it could have been caused by the awakening of an ancient civilization which rose like we rose and fell as we inevitably will. That could be the fate of all advanced species, a rise and fall that flows as naturally as the changing of the seasons. Such a universe is ironic, continually creating characters whose technology brings on the very end they're trying to avoid. When Schmidt and Frank searched, they found a single forerunner to their ideas of deep time. It came not from science, but science fiction. At this level of conjecture, there is little difference after all. And it came from a very, very British source, that of Doctor Who. In particular, the second story from Season 7 Doctor Who and the Silurians, which was first broadcast as 7 parts on BBC One from the 31st of January to the 14th of March 1970. In this particular story, the Third Doctor attempts to broker a peace between humanity and the Silurians, an intelligent bipedal race of reptilians that ruled the Earth before humans. This effort becomes undone by a xenophobic usurper Silurian along with the gung-ho human soldiers of UNIT. It's not really a new idea. Ancient mystical texts hint at earlier creation, the life that preceded the garden, prequels to Genesis, if you will. These incarnations are not reported in books like the Bible because they are none of your goddamn business, but the evidence is everywhere. Some students of conspiracy believe that there was a time when lizard people shared the earth with modern men, the older race dying as the younger emerged from the forest. The last of the lizards were worshipped as gods. These were deities of ancient India and Greece. Their technology, weapons and machines created miracles as far as the young humanity was concerned. You can see the lizard kings in carvings from Mesopotamia, the oldest historical records on Earth, where humans bow before reptile men. You will find them again in the Torah, where they appear as the Nephilim, the so-called Watchers. Just a quote from there. The Nephilim were on the earth in those days, and also afterwards, where the sons of God went to the daughters of humans and had children by them. According to Genesis, that is. They were heroes of old, men of renown, which no priest, minister, or rabbi can properly explain. Just ask a clergyman and see for yourself. These religious texts are always full of some weird shit. And any fellow David Icke fans out there know that there are those that believe that there are still Silurians walking on the earth today, holdovers who possibly share their technology with a hidden elite, possibly Freemasons, possibly Jews. Some pseudo-scientists speak of an atomic blast that took place in India 10,000 years ago. It might have been a natural phenomenon, or it might have been a war that wiped out the Silurians and drove them off the earth. This ancient catastrophe, which some take as evidence of an ancient nuclear war, shows up in the Mahabharata, a Sanskrit epic with the appearance of a single projectile charged with all the power of the universe. An incandescent column of smoke and flame as bright as 10,000 suns rose in all its splendor. It was an unknown weapon, an iron thunderbolt, a gigantic messenger of death which reduced to ashes an entire race. It's heartbreaking the fact that we face the nightmare of climate change. Some of us have already read our own perilous present back in the geological past, and have come to see even our own apocalypse as unremarkable, something that has been experienced before and was inevitable from the start. It's thrilling too, the idea of a pre-human industrial civilization. The idea of a pre-human industrial civilization. It means we don't know anything, who we are or where we are, or even the history of our own home planet. It must be said immediately that the outcome of any research has currently been negative. Schmidt and Frank have found no geological trace of a civilization that could be considered proof of the existence of past industrial civilization, nor do they believe that such a civilization ever existed. However, it is an interesting thought experiment. Above all, it is fascinating to reflect together with them the immensity of the past geological time, and on the rapidity with which traces of industrial civilization like ours would be eroded and finally hidden by the constant rearrangement of continental land masses and the ocean floors. In fact, to understand the traces of its existence that could have been left by a possible industrial civilization that flourished millions of years ago, the obligatory starting point is to try and understand what traces of our own civilization would be left should it were to disappear. Strange as it may seem, if a nuclear war and natural catastrophe put an end to humanity more or less suddenly, the archaeologists of a very distant future, possibly even millions of years away, would not find any of our artifacts, and probably not even fossil remains of our skeletons. Today, the works built by industrial civilization, highways, railways, bridges, skyscrapers, megacities, dams, etc., tower mighty in front of our eyes. The very surface of the planet is widely modified by human activity, with effects visible from space as shown by satellite photos of towns illuminated by night by electric lights, or those vast territories covered by the geometric patterns of cultivated fields. But the unravelling of these works on a geological timescale correspond to less than a blink of an eye. Let's go back to that desert in Israel I talked about earlier, which is dated to about 1.8 million years ago. But complex organisms have inhabited the Earth since an era more than 280 times more ancient. Therefore, traces of their existence are buried at various depths in sites that are mostly inaccessible and unknown. If the human species disappeared tomorrow, in less than 2 million years, erosion and sediment, which act relentlessly on the territories currently inhabited, would erase any trace of the cities and artifacts produced by industrial civilization. Considering that urbanized humanity occupies less than 1% of the total Earth's surface, the chances of recovering the buried remains of our civilization in the distant future are reduced to minimum. Moreover, fossilization is an extremely rare process that depends on many factors, including the climatic conditions, the ratio between soft and hard tissues of the dead specimen. For example, all of the countless billions of dinosaurs that have lived on Earth for about 200 million years, we own the nearly complete fossil of a few thousand specimens. It corresponds only to a handful of dinosaur fossils for every 100,000 years, for all the thousands of taxa that existed in those hundreds of thousands of years. As a result, the chances of encountering the remains of an industrial civilization that existed millions of years ago, but only lasted for a few thousand, are minimal. So, is it indeed impossible to find traces of any other civilization from the past? And should we resign ourselves to not leaving any mark of our own existence? Not exactly. It is true that artifacts deteriorate very quickly and that fossils are scarce. However, the global impact of industrial civilization on the climate and mineralogy of the planet will remain. Millions of years of oceanic sediment cores emerged here and there in various parts of the world. In a sedimentary core, a layer of a few centimeters is deposited on average every 1,000 years. In those few centimeters, paleontologists of a distant future could find all that remains of this current geological era characterized by the influence on a global scale of human activities for the last few centuries. Those activities can be reconstructed, albeit very roughly, by analyzing the chemical compounds present in those sediments. What paleontologists of the future would find by examining the thin sediment layer, first of all, a sudden change in the ratio between the carbon isotopes carbon-13 and carbon-12. Since the second half of the 18th century, humans have released over 500 billion tons of fossil carbon, previously imprisoned in coal, oil, natural gases, unearthed and then burnt. In addition to this, industrial activities have caused enormous deforestation, causing the release into the atmosphere of large quantities of carbon dioxide produced by the combustion of biomass. All the carbon from fossil fuels and deforestations is of biological origin. As such, it is low in carbon-13 compared to the much larger carbon mass of inorganic origin existing in nature. Therefore, a consequence of human industrial activity is that the amount of carbon-13 isotope compared to that of carbon-12 is rapidly decreasing in the atmosphere, oceans, and soils, with a percentage change that at the moment is at least 1% lower compared to pre-industrial era. It's called the Seuss effect. If current theories are correct, the release into the atmosphere of large quantities of fossil carbon and other greenhouse gases such as methane and nitrous oxide caused the average temperatures on the planet to rise by about 1 degree since the middle of the 19th century. The paleontologists of the future could find traces of this change too, examining the concentration of calcium carbonate in the foraminifera included in our marine sedimentary layer. This concentration would be increased due to the higher amounts of CO2 dissolved in the oceans, with consequent acidification of surface waters. Another significant global change due to the spread of industrial civilization originates from the enormous amounts of nitrogen introduced into the waters of rivers, following the use of fertilizers in agricultural activities. The presence of large quantities of nitrogen favors the proliferation of microbes in coastal ocean waters, which leads to a decrease in dissolved oxygen in the water column. This process creates anoxic regions in the oceans, which are the progressive increase in so-called dead zones. These oceans will be identified in the sediments through their higher organic content and lower bioturbulation, which is the alteration of deposits due to activity of organic organisms. The mining activities necessary to support industrial civilization have also produced an increase in the diffusion of lead, chromium, antimony, platinum, gold, and rare earth elements into river waters. These elements are now present in concentration higher than any of those due to natural cycles. It will alter the composition of coastal sediments, which will show geologists of distant future a sudden peak in the concentration of these metals in correspondence with the layer dating back to our geological time period. The distribution of fossils recovered by future paleontologists will also be affected by the global impact of industrial civilization and human activities in general. The success of widespread diffusion of our species in recent centuries in particular have been accompanied by the proliferation of highly invasive small mammal species such as mice, rats, cats, to the detriment of many native species that have gradually become extinct. The total disappearance of megafauna existing in America and Australia at the end of the last ice age is another of the immediate consequences, on a geological level, of humans and their demographic explosion. Therefore, the extinction of many animal species in the face of widespread diffusion of a few others will be seen in the fossil record and will testify if and when they are brought to light by paleontologists of a hypothetical future civilization. Finally, we must not forget industrial chemical products, which are very resistant to degradation, spread worldwide today. Compounds such as polychlorinated biphenyls, the notorious PCBs, chlorofluorocarbons, CFCs, and synthetic steroids. If found in the sediments of our era, they could be considered by future scientists as unequivocal evidence that there was an industrial civilization that created them with synthetic process. However, we do not know how long these compounds can survive degradation by chemical, photochemical, and biological processes, and if they were to still be recognizable millions of years later after their production. However, plastic could withstand for a very long time if incorporated in a highly resistant aggregate of waste that came into contact with high temperatures. These are known as plastoglomerates. Lastly, the Transuric radioactive elements remain. If humanity were to destroy itself through a nuclear holocaust, some isotopes of elements that can be used to produce atomic weapons have such a long half-life that they could be detected after several million years. Plutonium-244 and curium-247 in particular have a half-life of 80.8 and 15 million years respectively. If the current industrial civilization were to disappear from Earth's face in a few centuries, all that would remain in the distant future of its activities and of its existence would be traces, incorporated into sediment layers of planetary pollution that it has caused in a very short geological time. These traces would originate from the release of vast quantities of carbon of biological origin into the environment to produce energy, the global rise in temperature due to greenhouse effects, the alteration of the nitrogen cycle, the acidification of the oceans and the creation of dead zones due to a lack of oxygen, the extinction of numerous animal species and the uncontrolled proliferation of a few other species, peaks in the diffusion of rare minerals for industrial use and the possibility of isotopes of radioactive elements useful in the construction of atomic weapons, and of course synthetic pollutants such as PCBs, CFCs, and plastic materials. Given this list of all the things that an industrial civilization like ours would leave behind in the sediment layers, we can consider them all traces as geological markers. In their presence, it is fair to ask whether they are the testimony of the passage on Earth of other industrial civilizations before ours, created by another species long since gone. The Silurian Hypothesis at the center of Smith and Frank's study is based precisely on this attempt. It is a search for geological traces of events that occurred many millions of years ago. Such events exhibit characteristics mostly analogous to the traces that our own industrial civilization would leave in the sediment layers. Moreover, they cannot be immediately connected to natural catastrophes such as the impact of asteroids, comets, or megavolcanic eruptions. The first event reported by Smith and Frank is the Paleocene-Ecene thermal maximum, or PETM. occurring about 56 million years ago, and this period lasted between 100,000 and 200,000 years and was characterized by an average rise in temperature between 5 and 7 Celsius, which I think we have already covered. In less than 5,000 years, a large amount of carbon of unknown origin was released into the atmosphere, causing a negative peak in the ratio between carbon isotopes similar to that produced today by human industrial activities, but more pronounced, with a percentage decrease of carbon-13 isotope higher than 3%, besides an abundance of many metals including vanadium, chromium, zinc, and molybdenum. A spike in these sediment layers dating back to the PETM. Over the next 6 million years, other hypothermic events with similar characteristics occurred, which geologists collectively call the ELMO, Ecene Layer of Mysterious Origin. During this period, there were global increases in temperatures, a decrease in the ratio of carbon isotopes, and an anoxa peak in the oceans. The Middle Eocene climate optimum, another event characterized by a sudden increase in temperatures and the change in ratio between carbon isotopes, dates back about 40 million years. There are also many oceanic anoxia events, or OAEs, which traces have been found in the sedimentary layers studied by geologists. These events are even more distant in time. They occurred between the Jurassic and Cretaceous periods, about 183 to 93 million years ago. Finally, there are large mass extinctions linked to global climate change, characterized by rising temperatures, deforestation, fires, and oceanic anoxia. From this point of view, the three most important events in the late Devonian extinction, which happened between 380 million and 360 million years ago, the late Carboniferous extinction around 305 million years ago, and the most severe of all, the end Permian mass extinction about 252 million years ago. The study of sedimentary stratification provides numerous examples of past epochs in the Earth's geological history in which conditions similar to those created by the impact of human industrial civilization on the environment occurred. These clues concern a global increase in temperatures, a decrease in the ratio of carbon isotopes, alteration of the nitrogen cycle, oceanic anoxia events, deforestation, mass extinction, and peaks in abundance of some metals, as we have already said. However, none of these geological traces can be considered conclusive proof of the existence of an ancient and vanished industrial civilization. There is, unfortunately, no way to prove, through the study of these sediments, that the past climatic global change, of which these are evident traces, have been as rapid and sudden as those caused by human industrial activity. In contrast, the events such as the PETM and the ELMO seem to have developed over thousands of years, suggesting that they were caused by natural processes rather than productive activities of an intelligent species. Of all the possible geological markers of industrial activity, perhaps the most important is that which derives from the use of carbon for energy purposes. Since around 350 and 300 million years ago, there have been enough fossil carbon reserves to fuel industrial civilization like our own. But the events in which the release into the environment of large quantities of fossil carbon altered the ratio between carbon-13 and carbon-12 isotopes could have been entirely natural, such as volcanic and tectonic activity. There is no way to prove the artificial origin of these events. It must also be considered that a truly evolved industrial civilization must reduce its environmental impact if it wants to guarantee acceptable and lasting survival conditions. Thus we arrive at the paradoxical conclusion that the more an industrial civilization has evolved, the less geological traces it has left in the sedimentary layer. If, for example, in the distant past, an industrial civilization capable of supporting its production activities employing ecologically clean energies such as geothermal, solar, wind had existed, it would have left a geological trace in the ratio between carbon isotopes much thinner than we would be producing today through our extensive and persistent use of fossil fuels. In short, time turns out to be equally unfathomable as the abyss of space. Several industrial civilizations created by species which are doomed to be known nothing of may have existed in the geological eras. In the end, all that remains of the past events is reduced after millions of years to some rare fossils and a thin layer of sediment composed of minerals whose relative abundance can only provide vague and ambiguous information about the era that produced them. Furthermore, any prior civilization could have left the Earth for other celestial bodies, where it might eventually be possible to find artifacts of their existence, as planets like Mars have far less erosion and tectonic activity upon them. And of course, there is also the possibility that Lovecraft was right in his story The Shadow Out of Time and the Mountains of Madness. After all, Antarctica was once subtropical. And that brings us to the end of today's episode. I hope you enjoyed this particular look into something that has fascinated me for more than 2 decades now, even though the official paper has only existed for about 4 years. I'd like to thank you very much for your time and patience, and if you like this, then please don't forget to hit the like button, subscribe, ring the notification bell, and join us over on Patreon for exclusive early access and other perks. And it leaves me now just to say thank you very much and to wish you a good day wherever, whenever, whatever you are, and I hope you will join us for the next episode. Goodbye.